Hi, this is Prem Kumar, Assistant Professor, Department of Computer Science, Sithanganadar College. Today, I'm going to discuss you about the introduction of the deadlock in an operating system. Let us see in detail about how this takes place in an operating system. So, in this introduction part, we're going to discuss what is a deadlock. Deadlock, we know that deadlock is a situation where a set of processes are blocked because each process is holding in another resource, waiting for another required by some other process. So it can be solved using this techniques, that is a process. Whenever the process is executed by an operating system, the resources can be used in this following ways. First, it has to request a resource, how much it has required, and once it has been utilized, it has to be once it was used or utilized, it has to release the resources. So these are the ways we can say it is a requesting a resource, use the resource, and release the resources. When you come to the other part of this, see this diagram, we have explained about that process and the resources. In an operating system, when there are two or more processes that holds some resources and waiting for the resources held by others. For example, in the diagram, the process 1 is holding the resource R1, that is resource 1, and they're waiting for the resource 2, which is already acquired by the process P2, is waiting for the resource 1. So in this diagram, it was clearly knowing that we have in that deadlock state. Okay, so how it has been overcome, how it has been raised, means the deadlock can be raised if the following four conditions hold simultaneously. For example, see, first one is the mutual exclusion. What is mutual exclusion is two or more resources are non-shareable. That is, only one process can use at the time, not more than one process can hold more than one resources at the time. Next one is hold and wait. A process is holding at least one resources and waiting for the other resources. That is the second one. Then the third one is no preemption. That is, resources cannot be taken from the process unless the process release the resources. The last one is the circular wait. A set of processes waiting for each other in a circular form. So when we follow these four categories or four conditions, we can overcome the deadlock situation. Okay, so methods. How we'll see about how the methods, the deadlocks can be handled. So there are three ways to handle the deadlock. One is the deadlock prevention or avoidance. Either we can say a prevention or an avoidance. What is prevention is, the idea is to not let the system into a deadlock state. First, we will be not allowing the system enter into the deadlock state. That is the use of the prevention technique. This system will make sure that the above mentioned four condition will not arise. That is, previously we have discussed about the fourth point. So when we follow that, we can avoid the deadlock situation. These techniques are very costly. So we use this in cases where our priority is making a system deadlock free. So one can zoom into each category individually. So prevention is done by negating one of the above mentioned necessary condition for the deadlock. And the second one is the deadlock detection and the recovery. So if deadlock prevention or avoidance is not applied to the software, then we can handle this by a deadlock detection and recovery, which consists of two phases. In the first phase, we examine the state of the process and check whether there is a deadlock or not in the system. Second one is, if we found out the deadlock is there, then we can employ some of the algorithm for recovery of the deadlock. Then we'll be seeing about the four other prevention techniques. What that is: eliminating the mutual exclusion. The second one is solve the hold and wait. The third one is allow preemption. The fourth one is circular wait solution. Avoidance. When we see about an avoidance, the avoidance is a kind of frustrating. By using the strategy of avoidance, we have to make an assumption. We need to ensure that all information about the resources that the process will need to know to us before the execution of the process. So we may use the Banker's algorithm to avoid the deadlocks. In prevention and avoidance, we get the correctness of data, but performance decreases. Okay. Then we'll see about if a deadlock prevention or avoidance is applied to the software, then we can handle this by two. We can handle this by deadlock detection and the recovery method, which consists of the two phases. In the first phase, we examine the state of the process and check whether there is a deadlock or not in the system. If found the deadlock in the first phase, then we can apply the algorithm for the recovery of the deadlock. Okay, then we'll move to the next one, that is the manual intervention. So when we consider this manual intervention, when a deadlock is detected, as soon as what we have to do is, one option is to inform the operator that let them handle the situation manually. If possible, if there is a possible situation, we can handle it. The operator can itself handle it manually. They avoid the deadlock. No, we leave as it is. While this approach follows for a human judgment and decision, it can be a time consuming and may not be feasible in a large scale systems. Automatic recovery. When we come to the automatic recovery, an alternate approach is to enable the system to recover from the deadlock automatically. This method involves breaking the deadlock cycle by either aborting a process or preempting the resources. Let's delve into these strategies in more details. So about all the deadlocked process. So if in case we when you want to come out from the deadlock, which means recover from the deadlock, what the steps we have to do is we need to go for the process terminations. That is the only solution we can come out of the deadlock process when deadlock state when it has been occurred. Okay, that is all about all the deadlocked process. First we have to abort the all the process. This approach breaks the deadlock cycle, but it comes at a significant cost. The processes that were abort may have executed for a considerable amount of time, resulting in the loss of a partial computations. These computations may need to be recomputed later about one process at a time. So even you can also go for aborting all the process or at least one process at a time. Instead of aborting all the deadlocked process simultaneously, this strategy involves selectively aborting one process at a time until the deadlock cycle is eliminated. However, this incur overhead has a deadlock detection algorithm must be involved after each process terminations to determine if any process are still deadlocked. The factors for choosing the termination order. So in what way we can terminate the process? Either we can abort all the process or abort one process at a time. So anyhow, these are the factors we can go for the termination order. The process priority, based on the priority, we can go for terminating the process order, or otherwise complete time and the progress made so far. What is the completion time it is required and how far it has worked. So these can be considered in the case of a termination order. The next one is the resource consumption by the process. So how many resources it was consumed by a process. So it was also be based. It also be calculated based on this termination order. Then the resource required to complete the process. If in case it required any additional resources it has required, so that is also be considered in the part of a process termination order. Then the number of processes to be terminated. So how many number of process we going to terminate? This is also going to be calculated. Then the last one is process type, whether it is an interactive process or it may be in a batch process. So these are the factors we can go for the order before terminating the process. Then next one is we'll see about recovering from the deadlock. So that is we'll see about resource preemption. What is resource preemption is? So we will be going to take the resource from the process before it completes its work. So first one is selecting a victim. The resource preemption involves choosing which resources and the processes should be preempted to break the deadlock. The selection orders aims to minimize the overall cost of recovery. The factors considered for a victim's selections may include the number of resources held by the deadlocked process and the amount of the time the process has consumed. Rollback. If a resource is preempted from a process, the process cannot continue its normal execution as it lacks the required resources. Rolling back the process to a safe state and restarting it a common approach. Determining a safe state can be challenging, leading to the use of total rollback. where the process is aborted and restarted from the scratch. Then the third one is the starvation. The starvation prevention says that to prevent the resource starvation, it is essentially to ensure that the same process is not allowed chosen as a victim. If a victim, a selection is solely based on the cost factors, one process might repeatedly lose its resources and never completes its designated task. To address this, it is advisable to limit the number of times a process can be chosen as a victim, including the number of rollbacks in the cost factors. When they come to the third one is a deadlock ignorance. If a deadlock is a very rare, then let it happen and reboot the system. This is the approach both Windows and the Unix takes. We use the ostrich algorithm for deadlock ignorance. In a deadlock, the ignorance performance is better than the above two methods, but the correctness of the data. So we can also go with a safe state process. It is a technique which is used to find out whether if I allocate a process to a, if I allocate the resource to a process, whether this process has been entering into a deadlock state or not. If it was calculated that the process is entering into a deadlock state even after allocating certain resources, so I cannot able to go with allocating the resources to those processes. So that is it was discussed in that safe state. A safe state can be defined as a state in which there is no deadlock. So it can find if it is going to find out certain sequence in which sequence the process is going to execute. If it is finding that there are certain sequence, when you go with a certain sequence of executing the process, will not reach to the deadlock state. If we are finding in that sequence, if any process cannot able to allocate the resources with that sequence, so that time that sequence we can say it is in a deadlock sequence. So it is going to be calculated with the help of the safe state. So that is what here it was saying, that the safe state can be defined as a state in which there is no deadlock. It is achievable if a process needs an unavailable resources. It may wait until the same has been released by a process to which it has already been allocated. If such a sequence does not exist, it is an unsafe state. We can able to get a sequence state. The process is in a the process is all the process which is going to execute is in a safe state. If we cannot find the sequence state, it states that the process going to face the deadlock. So when the process gets the sequence, I can say it is in a safe state, though the resources is going to be allocated to the process so that the process will move to its designated task. So all the requested resources are allocated to the process. So with this, I conclude my session. Hope you all understand this. Thanks for listening this. Thank you.